So it turns out that the two problems are essentially the same mathematically, and except the neutron one's simpler because the states are further apart. You can use perturbation theory. In the end, recently, during the last 6 months or so, we've managed to solve these equations exactly for some simple limiting cases. And we've got some understanding now, some basic understanding of how they work. And I can cite for you a number of following conclusions. Conclusion number one is that the numbers appear to be that the neutron hopping can turn on if the coupling strength's large enough, which appears to be possible. For example, in the thermal case at room temperature, there's no neutron hopping, there's no neutron hopping effects, and you can prove that. You can work out, you can solve the equation, you can show that there's no effect whatsoever. And the reason is that the hopping is tightly coupled to phonons. And at room temperature, the lattice isn't wiggling or vibrating very much. You have to get some significant amount of vibration in order for the effect to turn on. And it has a lot to do with selection rules for how the neutron can go from one site to another without perturbing the phonon field. It turns out to be easier for the neutron to hop if there's a lot of phonons present. Transfer, as long as you have phonon band gaps. And that gives rise to electron emission, cage shell X-ray, deuteron ejection, neutron emission, host lattice activation. Conversely, if you have large coherent phonon amplitude, which a photon laser can make, but you can also make using lasers or using other techniques, you can get the neutron hopping to turn on, at least in theory. And if the neutron hopping turns on, if it combines with the energy transfer, you can get heat production, you can get tritium production, or it happens by itself. Without energy transfer, you're going to get some gamma emission. And we calculate the gamma emission rates. They're low, they're very low, but they should be observable. The one thing I'm interested in seeing is that in some of the various experiments folks are doing, do they get low-level gamma emission? Let me summarize what we think we know, and then I'll summarize what we think we don't know. It turns out, for those of you who actually look at the view graphs and make notes and stuff, you might see a connection between what we know and what we don't know here. But what we think we know is that some of the effects are real. There's a lot of effects that have been claimed, and knowing in detail for every single one of them whether they're true or whether they're real or whether they're not real is a project that's going to take some time. I tend to believe that the heat effects in the heavy water systems that receive the most study are real. I'm tending to believe that some light water heat effects are real. I think the tritium in Claytor's lab is probably real. I think Kevin Wolf's neutron observations that he hasn't talked very much about, I think that those are probably real. There's only, from theory point of view, there's only one viable energy transfer mechanism that can do the job that's needed, and that's that mode shifting phonon laser thing. Another thing I think I know is that a phonon laser is absolutely required as the basis for essentially any of these effects, and that if we look, we should be able to find phonon lasing. For tritium production and for heat production, only charge neutral reactions, I think, have a chance due to the Coulomb repulsion. And I think at this point I'm convinced that heat production and tritium production in fact can only come about from neutron hopping. And I think the estimates from theory support that rather well. I guess to summarize what I think I know is that theory, this mechanism, the exothermal driven phonon laser, energy transfer by frequency shift, neutron hopping, this theory with all of its associated physics, I think at the moment, certainly qualitatively, does a rather nice job of making sense out of a wide variety of these anomalous experiments. Moreover, more recently, since we now have exact solutions or near exact solution of the neutron hopping equations, I think that it's the case for quantitative estimates for heat production tritium now are much, much stronger. Well, that's good. Now I have to, in fairness, summarize what we don't know. And what we don't know is we don't know which effects are real. And what that means, I'm probably going to get get tomatoes and apples thrown at me for saying this in this particular audience. But to be serious about it, if you're going to say something's real and if you're going to spend a significant fraction of your lifetime working on it and pounding on it, you need a little bit better publications, documentations, experimental results than what you've got right now. And if somebody measures heat, that's good. I nod my head, bob it up and down, says, oh, that's a heat measurement. But I need to know what's the product, what's the loading, what went into it, how do I reproduce the experiment. I need to see the paper and all its data lovingly laid out in the journals. And you know, situation's improving. It's much better now than it was in 1989. But in my view, it needs to improve more. I would like to see it improve more. The energy transfer mechanism, which is the only one on the last view graph that could possibly be it, from theory point of view, is completely unproven experimentally. There is no evidence currently, experimental evidence in support of the mode-shifting energy transfer mechanism actually working. It would be fun to see if we could observe phonon lasing in conjunction with the production of the anomalies, because I think that would make a rather convincing argument that you had. It wouldn't prove it, but at least it'd be a step close to what we have now. Getting phonon laser gain from exothermal desorption, well, that's something theoretically it's compelling, but there's not the slightest hint of evidence experimentally that that actually happens. And if we could prove that that would happen, that would be a very, very nice result to have. A nuclear reaction mechanism, while I'm convinced that I understand the basics now about the nuclear reactions involved for heat and tritium production, I haven't got yet the slightest scrap of hard evidence now, either to support or to refute that conjecture. What I really need is a clean demonstration of what the fuel is and what the ash is, in a way such that there isn't anybody's doubts and there's no doubt in anybody's mind. Finally, the theory, which at the moment looks qualitatively so promising and quantitatively so promising, has very little in the way of any experimental support of any sort. I don't have a single experiment where I've got an anomaly that I've detected under conditions that are sufficiently well known that I can give my theory a real run for its money. So again, if you recall the last view graph and this view graph, the stars are the same, the issues are the same. And the first one, I'm happy because I know something. On this one, I'm unhappy because I don't know exactly the same things. Anyway, I've run out of view graphs, fortunately. And